The sun, a colossal sphere of plasma, burns with an intensity that shapes life on Earth. Its surface churns with magnetic storms, unleashing solar flares, explosions of energy that ripple across the cosmos. These flares, often millions of times more powerful than our strongest nuclear bombs, hurl charged particles toward our planet at staggering speeds. Most people know them for their dazzling auroras or occasional disruptions to satellites and power grids. But could their influence run deeper, touching the very core of our world? Welcome to the unseen connection between solar flares, Earth's core, and the future of our planet. Let's start with solar flares. Born from tangled magnetic fields on the sun's surface, these bursts release energy in the form of light, radiation, and coronal mass ejections, clouds of plasma and magnetic fields racing through space. When they reach Earth, they slam into our magnetic shield, the magnetosphere. This interaction can spark geomagnetic storms, lighting up the skies with auroras or frying delicate electronics. But the story doesn't end at the surface. Scientists are beginning to explore whether these solar events could penetrate deeper, influencing processes far beneath our feet. Deep within Earth lies its core, a molten outer layer surrounding a solid inner sphere, both made mostly of iron and nickel. This core is a dynamo, generating the planet's magnetic field through the churning of molten metal. That field is our first line of defense against solar flares, deflecting charged particles and protecting life from harmful radiation. But what if the connection goes both ways? Could solar flares, with their immense energy, subtly affect the core's behavior, altering the magnetic field in ways we're only beginning to understand? The idea isn't as far-fetched as it sounds. Research suggests that solar activity follows an 11-year cycle with peaks of intense flare activity. Intriguingly, some studies have found correlations between these cycles and subtle changes in Earth's magnetic field. For instance, data from geomagnetic observatories show small cyclical variations in field strength that seem to align with solar maxima, the periods of peak solar activity. These variations are tiny, often less than 1%, but over time they could add up. Could solar flares be nudging the core's dynamo, like a cosmic metronome setting the rhythm of Earth's magnetic dance? To understand this, let's dive into the physics. Solar flares release streams of high-energy particles that can penetrate Earth's magnetosphere during intense geomagnetic storms. Most of these particles are deflected, but some may spiral along magnetic field lines, reaching deep into the atmosphere or even influencing the planet's interior. The core, though thousands of miles below, isn't entirely isolated. Electric currents in the ionosphere, triggered by solar activity, can induce secondary currents in Earth's crust and mantle. These currents might, in theory, interact with the molten outer core, subtly altering its flow patterns. This interaction could have consequences. The core's dynamo is sensitive. Small changes in its fluid motion can shift the magnetic field's strength or orientation. Over decades or centuries, these shifts might influence the field's stability. Earth's magnetic field has weakened by about 10% over the past 2 centuries, a trend that puzzles scientists. While natural processes like core convection are the primary drivers, some researchers speculate that solar activity could play a supporting role, amplifying or dampening these changes. Why does this matter? The magnetic field is more than a shield. It's a key player in Earth's habitability. It protects our atmosphere from being stripped away by solar winds, a fate that likely befell Mars long ago. A weakened field could expose us to more radiation, threatening ecosystems, technology, and even human health. If solar flares are influencing the core, they might indirectly shape the long-term trajectory of our planet's magnetic health. But the story gets bigger. Earth's core also drives geological processes like plate tectonics, which rely on heat from the core's slow cooling. If solar flares can subtly alter core dynamics, could they influence these processes too? Some scientists hypothesize that geomagnetic changes might affect mantle convection, the sluggish flow of rock that powers earthquakes and volcanoes. The evidence is thin, but studies have noted curious correlations between solar activity peaks and increased seismic activity. It's a controversial idea and we're far from proving causation, but the possibility is tantalizing. Now, let's look to the future. Solar activity is expected to peak again around 2025, part of the sun's 11-year cycle. If solar flares do influence the core, these peaks could bring measurable effects, perhaps stronger geomagnetic storms or subtle shifts in the magnetic field. Over longer timescales, as the sun evolves, its activity could intensify, potentially amplifying these effects. Meanwhile, Earth's core is slowly cooling, and its magnetic field may naturally weaken over millions of years. If solar flares are a factor, they could accelerate or complicate this process. What can we do? First, we need better data. Satellites like NASA's Solar Dynamics Observatory and ground-based observatories are already tracking solar flares and geomagnetic changes. New missions could probe the core's behavior with greater precision, using seismic waves or gravitational measurements to map its dynamics. Models that simulate the interplay between solar activity and Earth's interior could help us predict long-term changes. If solar flares are indeed a player, understanding their role could guide strategies to protect our technology and environment. The unseen connection between solar flares and Earth's core is a frontier of science, blending astrophysics with geophysics. It challenges us to think of our planet not as an isolated rock but as a dynamic system, intertwined with the cosmos. As we unravel this mystery, we may discover that the sun's fiery outbursts hold clues to Earth's past and its future. For now, we watch the skies, knowing that each flare might carry a message not just of beauty but of the delicate balance that sustains our world.